Shall we start? And for your friends. Did you review the material about signal we had last session? Any idea what we taught last session? No. Last session we talked about Fourier series and let me write here because I don't have it. We talked about Fourier series and Fourier transform. Why we use Fourier series and Fourier transform? Why we want to shift to the frequency domain? Yes. What's the advantage? If we know, it's easier to deal with. Yeah. You know, when you see a signal in a time domain, you know, mostly you cannot distinguish what is the signal in a time domain. But we saw when we move into a frequency domain, we can easily find which frequency this signal is consists of. Here we can easily distinguish and we can easily find out which frequency we can take out from these complicated waveforms that we see in the time domain. Another advantage was when we are dealing with LTI systems, suppose we have an LTI system. At first, what was the advantage of using LTI systems? Why we are focusing on linear time invariant system?
We have the impulse response. We can predict the signal.
Thank you. If we have its impulse response, we can find its response to any arbitrary input. Yeah. It doesn't matter what's the input. If you have impulse response, how can we find the output regarding to any arbitrary input? Convolution. But as you remember, it wasn't easy to do convolution, even for time-limited signals. We did 3 or 4 examples, and you saw it's not easy to find the convolution of complicated LTI system. So we found if we can move this LTI system to frequency domain, I can find the Fourier transform of input. We call it as a transfer function. On that case, the output would be y omega, which is signal in frequency domain. It's only multiplication of Fourier of x omega and h, which means we change the convolution with multiplication, which is much more easier. So after that, we just need to apply Fourier inverse to find the output. It's much easier if you want to do multiplication rather than convolution. After that, we went through some important Fourier transform. Fourier transform of delta 1 impulse, unit impulse, 1. If I have a DC signal, we had some property.
Differentiation of
Exactly, 2 pi delta minus omega or delta omega, that's even. Ut what was the Fourier transform of unit step? Any idea? What's the relationship between delta and ut? Yeah, ut is integral of delta, which means its Fourier transform should be exactly. It should be divided by j omega plus t x0 delta. This is for these three. We talked about sine Fourier transform of sine omega 0 t. It should be two impulses. Okay. It was pi over j delta omega minus omega 0 minus delta omega plus, which means time wave in frequency domain is only two impulses. Where do we use the impulses? We had an example last session. Why this is important? For exactly, we use it for modulation. Here we can move any signal to arbitrary frequency we want through sine or cosine wave. How about cosine wave? It should be the same, only it doesn't have j, that's pi. And here it should be plus. If I multiply sine by ut, what will happen? If that's a periodic signal, we know the Fourier transform of periodic signals should be impulsive. But if I multiply sine wave by ut, What is this is periodic, this is not. Hereby it starts from 0. But this one, from minus infinity to infinity, you have a periodic signal. How can we find the Fourier transform of this? Any idea? I can write sine as an exponential. E to power of over to j multiplied by u. I have 1 over 2j e to power of j t u t minus e to power of minus j t u. What is Fourier transform of this? If we multiply a signal in time domain by exponential in the frequency domain, it should be exactly. We should have, which means I should find 1 over I should find this. Change the omega as x omega minus omega 0. Here is omega 0 is 1. Yeah, it should be 1 over no, minus 1 minus am I correct? If we can consider the discrete signal equal, we at the end we would have but 2 plus 1. Okay. I didn't make it. Yes, this is true.
Yes, you need to have the parenthesis j times omega minus 1.
J times, which means which one?
The numerator of the
Yeah.
j times omega omega minus 1.
It's fine.
Right.
Yeah.
Yeah.
And for cosine, we only will have here for cosine ut. Here should be 1.
It should be J. 1.
Here should be 1. For cosine, it should be J omega over omega to plus. I think that.
Yeah, this is correct.
And it was what about the
So Hassan, Laplace. Did you talk about the Laplace transform before this, or you haven't gone to Laplace?
I found them based on the Laplace.
Yeah, that's
Yeah.
what. Oh, yeah.
Yeah, that's fast. We are gonna talk about Laplace today. Let's go through Laplace. So let me give you one example right here. Okay, based on the properties we had, I want you to find sin pt over t. What is the Fourier transform of t?
Ben bu bir de harita bilgisi yıka. Ben o yanlış doğru unutmuşum. Benzeştirebildiği gibi. Bak haritada gelen hikayeye ama böyle Laplace tutmuş.
Hadi unutmuşum. Böyle fark ediyorum.
Hatta bir tanesi alet var. Omega araştırıyor. Kollu serç. Omega diyeceğim. Omega ne falan değil. Tamam, C'yi nerede verelim? C'yi de şey yapalım. Bakın abi diye C2 آره اگه آه باشه درست میگی. چون جی داشت اون جی داره داره میگه استفاده سخت
ثلاثة دي تشكيل مثلا.
you can convert it to direct vision to فاينانس مش فإذا مش ممكن غير هذا العمل بس استثمار طبيعي يعني
استثمار طبيعي. Right. Anybody volunteer to prove it? Not yet. Did you watch that? Yeah, if you didn't, it should be really good for you. But let's see, we can do it. So if we can provide some of your friends. Did you go through the right? Chapter 1 was easy. You know, we don't cover the discrete time. If you go through line videos, they probably cover discrete time and continuous time. But here we just cover continuous time and we don't go that deep. We just focus on what we need for ICD time. But these things, I think, you should know. But I will try to at least schedule some online meetings or online classes and review these from the grounds for those who don't have any idea what they are talking about. I will try to set up some sessions, but probably it would be online. Anyone volunteer? What is the shape of this waveform? This thing, yes. Thing is related to the shape in rectangular. Yeah. It's, we know if I have a rectangular waveform, its Fourier transform should be something like, let's see, let me write here. What was the definition of Fourier transform? X p e to the power of minus j omega t. Yeah. I want from 0 to t, the amplitude is 1, e to power of minus j omega 0 t dt. E to power of alpha t, the integral is 1 over alpha e to power of j omega 0 t 0 to t. It was better to take it from minus t. Let me write it back. Yeah, minus t over It's easier. Yeah. It doesn't matter because I just want to make it easy. So this is 1 over minus j omega over minus. Is what is this? It's sign here, e to power of j alpha minus e to power of minus j alpha over j to j. I have 1 minus j. I can rewrite it back. Well, j. Now I need 1 here and 1. Now this is each city is a point, is a rectangular. Its Fourier transform would be something like that. That's if I had xt, which is Fourier transform was xj omega. If I take these in a time domain and write it xt, its Fourier transform would be 2 pi x minus j omega, which means I can take this one to time domain. So xt would be sine of q over c over t. This Fourier transform is vector. Yeah, now t is, now I need to change t to 2 pi, and I need 1 to. So if xt is sine of t over t, here I need to change t to t. It was, yeah, it should be 1 of. We use duality. Duality is something, if you have Fourier transform of signal in time domain and frequency domain, you can swap them with only one coefficient.
Can you write on?
Yeah, I will do here, but okay. Yeah, after this, I'm gonna write. Yeah, I can. No, this one doesn't work.
Typical, I got my pen template that I could connect it to a laptop.
You have your pen now?
I'm not sure if that is gonna work. This is for the pen template, not for the Pascal. No, it's for the pen template.
No, wait.
Actually, it's for this pen template. It's not.
Yeah. It's
Sure, it
okay.
is gonna be.
I
It's
will.
gonna be.
It should be right. Okay, let's go through Laplace transform.
Do you wanna bring it down?
Yeah. Up to now, we found we can use Fourier transform to change the signal from time domain to frequency domain. But if the signal is not integrable, if energy is not limited, we cannot define Fourier transform for that. Yeah. We should find another powerful tool to change the signal from time domain to another domain, which analyzer of the systems are easier. That tool is Laplace transform. Let's see how we are gonna do this. If you remember, we defined e to power of st as an eigenfunction of LTI system. What is the definition of eigenfunction? If you apply an eigenfunction to a system, its output would be exactly like input, only with one coefficient. You can see here, I have xt equal to e power of st as the input, and the output is the same as the input, only with one k factor difference. So I can, if we write the convolution, we will see at the end, the output is like input only with one coefficient, which is dependent to f. We define Laplace transform like that. We had hf, we can write any arbitrary signal like xt to S domain, xf is minus infinity to infinity, xt to power of minus ft. This is definition of Laplace transform. If we write f equal to j omega, we will have Fourier transform. In general, f is complex number. Yeah, which f is a complex number. I cannot write with that. Let me try.
Use my laptop and pen tablet. I think it's easier. You can write it this way. Your hands gonna pain. It's not gonna be effective. I downloaded,
do you have-
downloading the slides on my laptop.
Do you have this, right?
Yeah, you
Okay,
sent.
can you-
You sent. Is it? What is it? You sent me 3 slides. Which one are you using right now? Chapter 2.
Chapter 4.
You did not send me chapter 4. Can you send? Wait, is it in Google Classroom?
No, you have in your email. I emailed it yesterday to everyone. Yeah.
Can you send it to me WhatsApp?
So f is a complex number. If we consider delta as 0, you can see we only have j omega, which is Fourier transform. Okay. In general, we can have f a complex number, sigma plus j omega, and if we consider, if we rewrite the x's, we can see at the end the Laplace transform of xt is Fourier transform of xt to power of minus sigma t. What does it mean? It means I'm adding 1 degree of freedom to a signal, which if the signal is not integrable, I can make it energy limited, and I can define the Fourier transform for this signal. How? I'm limiting its closing. Let's see how. For example, if we have one signal like this, how much is the energy of this signal? Infinity. It's expanding with the increasing of t. If we want to find its energy, it should be infinite. So I can add one function like that. If I multiply that with xt, with ft, I can make it integrable, or I can make it energy limited. So in that case, I can define one Fourier transform for that, which I call it Laplace transform. So the Laplace transform is a generalized form of Fourier transform, or Fourier transform is only a part of Laplace transform if we put sigma 0. So let's see some Laplace transform together.
Wanna write?
How can we connect that?
We have a question.
Why don't you connect?
We have understanding.
Yes.
How? Where is this connected? This is the charger. It is connected to that camera.
That's a shame. What happened? No, now that's really good.
And you have to orient it like this or like this. Do you have a long cable? I got from the power up. A long cable.
Yeah, no,
This is work?
Yeah.
Okay.
How can I clean? Which of them?
You can choose the rubber option.
Oh.
You can create the option, but that rubber option.
Oh.
Or you can just click on control set and get that way.
Okay, thank you. That's now good. Okay, let's see some Laplace transform of some simple signals. If I have e to power of minus at ut, if I write the Laplace transform, I just need to replace xt with e to power of minus at ut. Ut means the integral should be from 0 to infinity, and I can multiply two exponential. I just keep e and add the power. And where this one,
Click on draw.
if I put t, it's not easy for me using. If I put t0, e to power of 0 is 1. If I put t infinity, it's 0, how come? If I put t infinity minus, I didn't get what?
Minus. Minus will be multiplied with the infinity.
Yes, but how about s? You know, you can't say
I think it should be oriented.
yeah,
Yeah.
that's why I'm thinking by that.
Yeah, check this way, then it should be oriented like that.
Yeah. E to power of
It's difficult, no?
no, I cannot write. It's okay. I will find. E to power of minus 10. You know, we don't know the s. Yeah, that's e to power of minus a plus f from 0 to infinity. If we put 0 for t, it's 1. If I put infinity in e to power of minus a plus f infinity. Yeah.
Can't we move the infinity to the minus, so it will be minus infinity?
Yeah, it would be minus infinity. If this value would be minus, it would be plus infinity. Yeah. So I need one condition here. I can write f as a sigma plus j omega. Yeah. So it should be e to power of a plus sigma plus j omega multiplied by infinity. I can open this, write e to power of minus a plus sigma multiplied by e to power of minus a t. Let me write it. How much is the magnitude of this value? How much is the magnitude of e to power of j omega? Yes. If you expand it, it's like cosine sine omega t plus sine omega. That's a plus jb. What is the magnitude? Is
The
root of a2 plus b2. a2 plus b2, what? Yes. The amplitude of this one is 1. So it should be a limited value like this. How about this one? Here, both a and sigma, they are real numbers. They're real numbers. So if this value is positive, it should be e to power of e to power of minus infinity, which is 1. E to power of minus infinity. No. E to power of minus infinity. Yes, and infinity it goes to 0.
It's supposed to also.
Depends on this.
Yes.
Yeah. If this coefficient is positive, it goes to 0. If this coefficient is negative multiplied by negative, it should be positive, it should be e to power of infinity. So if we wanted limited value, so this value should be limited value. And if you want to have Laplace transform for this way. So this value should stay positive, which means a plus delta should be positive. So delta should be bigger than minus a. Otherwise, it would be infinity. So as you can see, what is the sigma really part of S? Here, I defined it like this. We call sigma really part of S. What we call omega. If sigma is really part, imaginary. So, in order to have these integral, the really part or sigma should be bigger than minus a. So this is S plane. This is really part. This is imaginary. So if I want to have really part bigger than minus a, it should be let us consider any other positive value. Here is minus a. So this area is the area we can define Laplace transform. Otherwise, if you are in this area, what will happen? Yeah, this integral would go to infinity, so I cannot define Laplace transform for this area. We call this area as a,
convergence.
we call it as a region of convergence, which means in this area only this integral converge. Otherwise, we cannot find the Laplace transform. So e to power of minus 80 ut, I think it's better to keep in mind the Laplace transform of this waveform. E to power minus 80 ut is 1 over s plus 8. Now I only change ut to minus u minus. There, and I can still write here. But let me try. Okay, I only changed ut to u minus t, and I added 1 minus here. So let's see what will happen to its Laplace transform. If I write the definition, it should be integral of minus infinity to infinity, xt to power of minus st dt. What is x? X is minus e to power of minus 80 u minus. U minus t means it should be from minus infinity to 0 minus e to power of minus 80 to power of minus sdt dt. This integral is e to power of alpha t 1 over alpha e to power of alpha. 1 over of alpha e to power of alpha t. Again, if I put t as minus infinity, this time really part of s should be smaller than minus 8. Last time what happened? It would be greater. But you can see the Laplace transform is the same as the previous one. E to power of minus 80 ut and minus e to power of minus 80 u minus t both have the same Laplace transform. So what's the difference? Only ROC. Yeah. So if I have a Laplace transform, if I have its ROC, I can say that's unique. Otherwise, it can have two Laplace inform. You can see here the ROC really part of f should be smaller than minus a, which is one plane on the left side of this line. When Fourier transforms exist, we remember Fourier transform is Laplace transform if we replace f with j omega. If we replace f with j omega, which means we have Fourier transform. So j omega is the vertical axis, this axis here. Here, f in general is sigma plus j omega. If sigma is 0, I would have only j omega, which means f equal to j omega is this axis. So I will have Fourier transform only if this imaginary axis, this one, is a part of ROC. Does this one have Fourier transform or not? No. How about the last one, previous one? Yeah, this one has Fourier transform. Yeah, why? Because the imaginary axis in the ROC of Laplace transform. Let's make it a bit complicated. If we have two exponential signals, its Laplace transform would be, since it's linear, I can find the Laplace transform of the first part, which is this, and the second part, which is this. How much is ROC of this one? Really part of S should be bigger than -1 for the second one. Really part of S should be bigger than -2. And for the whole signal, we should find their overlap here. The intersection or the overlap is when really part of S is bigger than -1. Okay, ROC has some properties that I'm gonna explain here, some of them. It's only set of lines parallel to j omega axis, which means they can be in the right side of one line parallel to j omega axis or in the left. They cannot be like circles or curvy. You can't find any. You can't find any ROC like this or like this. They should be in the right. They are in the right side, or they can be between two vertical lines or the left side. Yeah. If we can write the Laplace transform as a fraction of two polynomial, here one polynomial of s, we call root of the denominator as a wholes. So the ROC shouldn't cover any poles, which means we shouldn't have any pole inside the ROC. If xt is a finite duration signal in the time domain,
Can you do it through the touchpad? Do it manually through the touchpad.
yeah, if xt is finite duration signal, which means it starts from one point and it ends in another point. It's not gonna last until the end. Yeah, in the time, its duration is limited. On that case, its ROC would be the entire complex plane, except S0 or S infinity, which we will find which one cannot be in the ROC. If xt is right-sided, which means it's gonna start from one point and last until the end, like ut, its ROC should be right-sided, which means it's gonna start from one point and to the right. If xt right-sided, ROC right-sided. If xt is left-sided, something like that, its ROC should be again left-sided. If xt is two-sided, which means we have xt from minus infinity to infinity. In that case, ROC should be limited between two consecutive poles. So this is the property of ROC. Okay, let me see. Anyone can. We want to find the Laplace transform of this signal. Is it right-sided, left-sided, or limited in time duration? Yeah, it's gonna start from, it started from 0 to t, something like that. So what do you expect for its ROC? When it's time limited, its ROC should be,
Between two.
let's go up again. If xt is finite duration signal, which its time is limited, its ROC should be the whole complex plane, okay, which means it doesn't have any limitation. So its ROC would be the whole complex plane, except 0 or infinity. We should find that, which one cannot. But its whole, when it's time limited, its ROC should be the whole S plane. Okay, let's write the definition of Laplace transform for this one. X is minus infinity to infinity xt to power of minus ft dt. If I replace xt with e to power of minus at, which is defined from 0 to t, this is the Laplace transform of this shape. And as you can see, but I cannot define this except only in infinity. Yeah, only in infinity it can go to infinity.
Can you repeat?
You know, we are in S domain. Suppose here I have S plane. Where cannot we define these x's?
Yes, equal to one.
We still can. what is numerator if you write f equal to minus a? No, that's denominator. How about numerator here? If you write f equal to minus a, this would be 0. E to power of 0, 1. 1 minus 1. 0 over 0 means no, undefined. Yeah, which means we can find it should be a limited value. It's not infinite. Yeah, so okay.
Still into the phone.
Oh, why did he open the door? So I can define even on f minus a. Where I cannot define, if f goes to infinity, if f approaches to infinity, this one would be depends on its really part. Yeah, but it can be anywhere. Its really part can be this side or this side. But at least in one side, it cannot define. Yeah. So the ROC is the whole S-plane except infinity, which this can be infinity, e to power of S.
So we don't consider minus 8 as an undefined thing.
No, you found it. Oh, that's undefined. Yeah, but we can define S everywhere for this one. Yeah, we are not looking for finding S exactly on one. You know, when we are talking about ROC, which means in which area we can define Laplace transform. Yeah. We only cannot define it in infinity. Other places we can. Right now, we don't know the exact value on f equals to minus a. How about this one? Xt e to power of minus b ft. Okay, in time domain, signal is its duration is limited, it's right-sided, left-sided. How is this signal? It's two-sided.
Same as before.
No, for previous one, its duration was limited. Yeah, we defined it
This one's
from 0 to t, but for this one, we didn't put any condition, which means t can be from minus infinity to infinity, which is something like that. If signal is two-sided in time domain, its ROC would be if signal is two-sided, its ROC would be limited between two successive or consecutive poles. And this one is two-sided, so its ROC would be something like that. How we find minus b and b? We should write the Laplace definition. If we write the definition, at the end we find x is minus 2b over s2 minus b2, which the roots are the root of x are f is equal to b, or these are the roots, which means if I consider f as a b, this value would be 1 over 0, which is infinity, which I cannot define Laplace transform for these 2 points. So we call them as a poles, yeah? These two, the roots of denominators, we call them poles. So this is from minus b to b. How we find the Laplace inverse? We should find it through one integral through a vertical axis from like this, from minus infinity to infinity, which we usually don't do that. Yeah, it's easier for us to find Laplace inverse through some properties of Laplace transform. For example, if we have one Laplace transform like this, we can easily use partial fraction expansion. Do you remember how we find A and B? We take yesterday. How?
Just one, the whole denominator with A and B, then we solve.
That's true. We found, I told you yesterday one easy way. Do you remember? If we are looking for A is numerator of S plus 1. Yeah. What is the root of S plus 1? S minus. I come here, I omit this one, and for the rest, I just replace with S with minus 1. So it would be 1 over 1, which is 1. Yeah, for this one, I need to for this one, here I omit S plus 2. For the rest, I replace S with minus 2. Yeah. Minus 2 plus 1 is minus 1. 1 over minus 1 is minus 1, which is minus. Now, we know Fourier transform of e to power of minus at ut is 1 over s plus a. I just need just replace a with 1, which would be this one. For the second one, you know, if I have 1 s plus 1, its Laplace transform can be e to power of minus at ut or e to power of like no, e to power of minus 1 again. Okay. How we found it can be both of them, yeah. If we go the previous section, you found if I have e to power of minus 80, its Laplace transform is 1 over s plus a. Again, minus e to power of minus 18 u minus t. It has the same Laplace transform, which means if I have this Laplace transform, how do you find its inverse? Is this one or this one? How do we find?
Since S should be greater than -1, so we take the
So if really part of S smaller than -1, you know, from ROC we found. We need to just take it again here. That's easy to write there. If I have a signal in time domain xt, if it's right-sided, its ROC should be from 1, 4, and right-sided. Xt right-sided, ROC right-sided. If xt left-sided, ROC should be left-sided. If xt is limited duration, it starts from one point and ends at another point. In the S domain, its ROC should be the whole S plane. If it's two-sided, its ROC should be between two poles. Yeah, that's the answer. Now they ask us 1 over S plus 1. So it has two Laplace transforms, which means we need to see its ROC. Its ROC is right-sided or left-sided?
right side.
So
Right-sided. So since ROC is right-sided, its Laplace inverse should be right-sided, which means I should choose this one is right-sided, this one is left-sided. For 1 over S plus 2, again, it's same. Or if I change the and right here. Anyone can explain the last one, how we find Laplace inverse for the last one? Anyone has any idea? For the last one, again, I have xs is 1 over s plus 1 plus. It is 1 over s plus 1 minus 1 over s plus 2. And its ROC ROC between minus, very part of it should be between -2 to -1. So suppose I want to find the Laplace inverse of this part. What is this pole? F -1. For -1, it should be left-sided or right-sided? Left-sided, which means I can choose e to power of minus t ut or minus e to power of minus t u minus. This is right-sided, this is left-sided. For s plus 1, I'm in the left side, so I should find the left-sided. For s plus 2, these two are its Laplace transform, depends on the ROC. I should choose one of them. For -2, ROC is right-sided or left-sided? It's right-sided. So I need to choose this one. So xt is e to power of minus ut minus e to power minus tu. This signal is right-sided, left-sided, limited durations, or two-sided in time domain. Yeah, it's two-sided. Yeah, this one is from -infinity to 0, and this one is from 0. As we expected, if ROC is limited between two poles, its xt should be two-sided. Okay, some properties like Fourier transform. Here we have four Laplace transform. The first one is linear. What does it mean? Here, if I multiply xt by 2, what will happen to its Laplace? That's linear here. It should be multiplied by. If I add some signals in time domain, I can easily find the Laplace transform separately in S domain. Okay. That was the definition of linearity. If I do time shifting, it should be e to power of, I need to multiply the Laplace transform by one exponential waveform.
Can you repeat the map? Is it okay?
Yeah, I will. That's so weird. Can see what happened. How come? What is Laplace transform of unit impulse? Unit impulse. It's one here. If you don't accept, I can write. X is minus infinity to infinity x t e to power of minus s t d, which is minus infinity to infinity delta t. Sampling property of unit impulse. If I multiply unit input, but any function, it should sample it only at the point we define delta, which means this one should be this one is I need to put T0, which is this one should be 1. Okay. That's sampling property of delta T. If you multiply delta by any function, delta would sample it under exactly the point delta is defined. E to power of 2t delta t minus 1 is what is
E to the power 2.
e to the power of 2. Yes, this is defined as t equal to 1. So we need just to replace t by 1. So right now, delta is defined as t equal to 0. So I need to find this function at t equal to 0. E to power of 0 is 1. So integral of delta from minus infinity to infinity should be 1. How about ut? One over S. How did you say that?
I memorize.
Exactly. Based on your previous note. Yes. We can write x 0 to infinity e to power of minus ft dt, which is would be 1 over s. What is ROC of this based on your knowledge up to now? 0 to right side or left side? Why right side?
Because of u of t. It's
Exactly.
not u of minus t.
Exactly. Since the signal in time domain is right-sided, its ROC should be right-sided. When is the pole?
Yes.
0, so it shouldn't have any hole in the ROC. UT plus 1 UT plus 1
Maybe left side. It's left side.
left-sided. What is left-sided?
1 over minus 1.
You know, at first we know UT is 1 over S. Yeah, okay, we know UT is 1 over S. What is the difference? Exactly. I have only one time shift, which means I should multiply 1 over S by e to power of minus S or plus S.
Plus S.
Can you repeat?
you know, I'm looking for Laplace transform of ut plus 1. Yeah. At first, I know ut is 1 over F. If I change t to t minus t0 or t minus 2, t minus 1 or t plus 1, which means I'm doing time shifting. What will happen to its Laplace transform? It should be multiplied by an exponential. Yes. Now it should be e to power of minus or plus. Plus. What is ROC of this? ROC, we should find the plane that we can define its Laplace transform. ROC, when we cannot define this one as 0. 0, how about this one? At 0 is 1. 1 over 0 means infinity, so I cannot define at 0. How about this one, where I cannot define this one? Infinite, yeah. It should be, again, we part of f bigger than 0 minus infinity. We cannot have it in. E to power of ut. You know the Laplace transform of u, which is 1 over f. If I multiply one signal in time domain by an exponential, in S domain, I need just to do a shift. Yeah. Okay, for ut, I know it should be 1 over f. Now I'm multiplying with one exponential, which means I need to do shift in S domain. How much? Minus 2 or plus 2? Yeah. This root should be this coefficient. This root is 2, which should be equal to this one. What is ROC? Exactly. Really part of F should be greater or smaller. This signal is right-sided or left-sided. When signal is right-sided, ROC should be again right. Now tell me what is cosine T.
I have one comment on the
Which one?
first one.
Yes.
So it seems
Okay, let me introduce my colleague. You come here, please. Milad is my colleague in Sana Semiconductor. He is doing RFIC design for more than 15 years. I've learned a lot from him, and if you are interested, I'm sure you will learn a lot. And let us see.
I'm not a good teacher, but what Hassan was saying, actually, you forget something. I just want to take your attention to see if this guy has the Laplace transform or not. I mean, from whatever he says, this signal is right-sided. It should be like this, and convergence area should be like this. But if you go back to the fundamental of the Laplace and the ROC, basically this for right side, it doesn't have the Laplace, right? Because this signal, does it have?
We
It
can,
has, it has. Is it?
yes,
I mean, since this exponential is expanding,
yeah, we can.
it still has.
Yeah.
So long as the S is larger than, yeah, true.
Yeah, it
Still
has.
has, still has. So,
But how about Fourier transform?
yeah, for the Fourier transform, that's what I missed. For the Fourier transform, we cannot have this guy to have the Fourier transform, but Laplace can have. Yeah, true. So this is what's my mistake.
Perfect.
Yeah, just make sure that this integral at the end would be doable.
Yeah, it has.
Yeah, this is this
Laplace, but yeah.
Okay, sorry for interruption.
You're welcome. Cosine T UT, anyone can solve this, anyone volunteer? That is the, right now you know e to power of 2t, e to power of 8. How can you define cosine t? We are looking.
I didn't know, just
No, that was true.
really,
Yeah.
the real part of S.
What is the part of it?
I mean, the real cosine T is the real part of something.
We could write cosine in another way, which was
S over 1 over S over 1 plus 1 squared.
you know the answer, but how do you find it? How can you write the expression?
Cosine on direct.
1 over.
So this is good actually. At the end, we want to remember the basic of the Laplace of the basic function. If you remember it quickly, it's much better.
Yeah. But can you find how you can do this one?
Can't we say cosine T is 1 over S square minus 1?
1 over S over S squared plus 1.
Yes.
Yeah, you know the answer and your friend do, but how?
Can we convert it to the exponential?
Yes. Who was saying?
That's basic.
Yeah, that's true, but why you're helping me? Cosine t is e to power of jt plus e to power of minus jt over ut. Okay, I can write 1 over 2 e to power of jt ut plus e to power of minus jt again ut. You know how to be there. It is 1 over 2, 1 over f minus j2. Why jt? It should be j1. jt here. Jt E here minus J plus. So this is S2 plus 1. Okay. How about sine T UT?
How did we get the one? How did we get this is purpose?
This one?
Yes, did we just multiply?
Yes. If we multiply these two together, here we have S plus J plus S minus J. Okay. Here we have 2S. It is S2 minus J2. Okay. J2 is
Minus one.
minus 1 minus, it should be plus. How about sine T UT? Sine T UT. Can you see from there? So why you sit that far? Sine T UT.
Or a square plus one.
Plus.
Yeah. The exact same way. It should be 1 over S2 plus 1. Yeah. Sine T UT. E to power of minus 3 U T plus 2. Anyone volunteer for this? But it cannot become global. Anyone can help it yet. That's one. Can you solve this one? E to power of minus 3 UT plus.
Can you pass it together? Or sine theta?
Or
Sine theta.
90. For Laplace inverse, we wanna find the Laplace inverse of this function. Who can help? Okay. We did.
I'm done. Thanks.
You should go really step by step. How did you write that? I don't understand. What did you do? Just explain it a bit, please. Can I ask something? Can you write the Laplace inverse of e to power of minus tut?
Again?
Yeah, e to power of minus tut. Yes. Can you write it? Yeah.
Okay.
Yes. It would be.
X of S
Yeah.
minus 1. Isn't that correct?
No.
No.
1 over.
S plus it is 1 over S plus 1.
Yes.
Yes.
Is it xs? What did you write that? It should be xs.
Yes, it is S.
But what is minus 1?
It's based on the force here. S minus S naught. So S naught is minus 1. This one is S naught.
No, right now. Oh, okay.
Yes. So
That means you should at first write ut after that.
like that 1 minus S naught. And S naught is equal to minus 1. This one.
Okay. Right now, e to power of minus tut is 1 over s plus 1.
Yes, which is
Yeah.
this part. Right
Yes.
here. Then
Now,
ut plus 2.
no, you should shift the on. E to power of minus t plus 2, ut plus 2. You cannot only shift u and keep e minus t the same. It should be e to power of minus t plus 2, ut plus 2.
Wait. Again.
You know, let me explain like that. You have xt here, yeah? And I have. You have xt here. Now you want to find this one. You should find xt plus 2. Which means if you have t anywhere, you should replace it with.
T plus 2.
Yes. This should be minus t plus 2 ut plus. Now what is, here you are. Now what is the Laplace transform of this?
So this is a constant. Can we just write it
No.
outside?
At first, for the x plus xt plus 2, what would be the Laplace transform?
Oh, wait. I just split this one out.
No, first you find the Laplace transform of xt plus 2.
Can't we just do this one like
Yeah,
this?
you can do that. Yeah. But do you know the Laplace transform of that one?
Of this one?
Yes.
So
You have Laplace transform of xt, yes,
yes,
which is
it's going to be 2s plus.
it's 1 over s plus 1.
It is what?
1 over s plus 1. You found it in the second line. Xt,
Yes.
its Laplace transform is 1 over s plus 1. If we change xt to xt plus 2,
S plus 2.
no, see the time shifting. If you change t to t minus t0,
This one?
Yeah.
Wait, I'm confused. So this part is gonna be xs times es of t plus 2, or what?
no,
Only this part.
no. How can you have t in the s domain?
That's true. Okay. Can I give up? Like, can I stop here?
No, that's
It's okay. So you can just go back to time sheets.
Isn't it true if I did it like this one?
Yes, that's true.
T plus 2,
Yes,
then yeah. So it is 3 minus 2 times s plus only t plus 2 is plus. Is that
your answer looks quite good. The way you are finding them,
So you can start maybe from u of t, the very basic one, and start shifting to reach that final value. Let's say your basic function is just u of t, right? You want to build the final function.
which one of functions?
I'm like you, I just thinking. So you want to at the end reach this.
Yeah.
Right? You want to find this.
Mm.
We start with what we know is, let's say, only u of t, right? The Laplace of the u of t. I start with this very basic function. Is that okay? It hit me if I forgot. So if we start with u of t, we know that 1 over s, right? Right. And then next level, let's say I just want to just shift it to u t plus 2. Right? Then from the shifting time shift, then I should just multiply the ut minus ut plus 2, then I just using that formula, just use 1 over s times into the
So it's
2s, right?
yes.
So far we have this part of the thing.
Mm.
And then we have another property,
It's
which is you are trying to multiply this to this, the main thing, right? So if you multiply, the value is negative, t times u t plus 2, right? From this property, you need to just keep the s domain to left or right.
yes.
So basically, we need to shift it to the,
Plus 1?
yes. So everything is just this. S plus 1, e to there, s plus 1. Right? You start with very basic thing, try to modify to reach to the final thing you want.
Mhm.
I guess the way you were doing also similar to this, but you wanted to combine some of the things, so mix up.
Yes.
So we always start with very
I
fundamental
think the
things.
only mistake is the minus.
It's what you did basically. If you see just this negative is something where it's basically is e to the positive. So when you
This thing
So for-
created-
so for the simple functions, you can actually even do the integral is easier than going through this thing. If you directly write the integral of the Laplace for this function, also easier to solve. But we want to try to use the properties. We don't want to write the integral. Because for more difficult or complex function, these things are more useful than solving the integral. Is that correct? Maybe I missed one.
And we can solve it in another way. Yeah. I know e to power of minus t
Yeah.
ut. What is this one? 1 over s plus 1. If I shift t to t plus 2, yeah?
Yeah.
But what should I do in this side? Plus 1 e to power of 12. I can expand it e to power of minus 2. So I just only want this side. So I can multiply the two sides by e to power of.
If this is the way you try to solve it.
Which they should be the
Both
same,
are
yeah.
same.
You can find different ways to find the Laplace transform, but at the end the answer is unique. You should reach to the unique answer. So this is the okay. Any question of no? Okay, we will continue the next session with rest of properties, and we will go the sampling theory, and we start a bit about control systems. I think we will have 2 sessions on control system. We will go through some definition of time response and some stability analysis on control systems. Did you receive the email about the assignment? Anyone could go through the assignment and so not yet. Okay, thank you for coming. See you next session. I may ask you to change the time of the class because some of your friends cannot join to 10 to 12 a.m. because it seems summer semester started at university, and they were asking if it's possible we can change to 3 to 5 p.m., something like that. Does it work or no? I will ask in a group as a poll.
On
And-
Thursday, we want it afternoon.
Only Thursday. For Thursday, we can find a solution, but the other days, if you are okay, we may.
I think you need to ask in the group.
Yeah, I
because
think.
we are
Yeah.
like,
Yeah, but since you are